Okay, welcome to the antiderivative review. First one, we do not need u sub. We just got to rewrite it as the antiderivative of negative 8x to the negative 1/2. So when you take the antiderivative, you add 1 to the exponent, so it's positive 1/2, and then multiply by the reciprocal of the new exponent. So negative 8 times 2 is negative 16. So we have negative 16x to the 1/2 plus c. If you want to, that's negative 16 rad x plus c. That's nice too. Okay, number 2. Number 2, we just need to rewrite each of the terms. Whenever you rewrite a term, it's nice if you can write it as a coefficient, a number, times x to an exponent. So when I the first one's fine. 2x to the 5th is fine. The next term we could rewrite as 9x to the minus 3 plus 3x plus 7x to the 3/4 minus x to the negative, because it's in the denominator, negative 2/5 plus 1. Now we can go ahead and integrate each term separately using the power rule. So for the first term, we add 1, we get 6. So now we multiply by 6 or divide by 6. 2/6 is the same as 1/3. Next term, we add 1 to the old exponent, we get negative 2. So we have to multiply by negative 1/2. So we have plus 9/2. Next term, we add 1 to the old exponent, we get 2. So now we got to divide by 2 or multiply by 1/2. So we have plus 3/2. Next one, we add 1 or 4/4 to the exponent, we get 7/4. When you multiply 7 by 4/7, you get 4. Next one, we add 1 or 5/5 to the old exponent, giving us positive 3/5. So we need to multiply by 5/3. When you integrate 1, you get x, and don't forget the c. So there we go. Just if you're looking at the review sheet, when I rewrote it, I think I miscopied one term. I think I looked up a line. So I'll write it. This is what we wrote. Plus, if you want to write it without negative or fractional exponents, I think this is the one I wrote wrong. It should be 4 times the 4th root of x to the 7th minus 5/3 times the 5th root of x cubed plus x plus c. But you do not have to write your answers on the test without fractional negative exponents. They're okay to stay. All right, number 3. Now 3, unless we actually want to multiply x cubed plus 3x by itself 9 times, we need to use u sub, because whenever you go to integrate a product, you're never just going to integrate each one separately. You're going to need u sub, products and quotients. So we're going to allow u to equal our inside function. Du equals 3x squared plus 3 times dx. Now, I always say you need all the factors of du in your problem. This is not completely factored this time, so let's just factor out the 3. And when we do that, we see that we are missing a factor of 3. So I'm going to put the 3 in anywhere you want after the integral sign, and the 3rd on the outside. With u sub, once you make sure your factors of du are in place, you rewrite it. So we have the 3rd. Always save the du for the end. So first we've got u to the 9th. And then the rest of it, the 3 times the x squared plus 1 times the dx, all that is your du. Once you've converted everything to u's and du's, take the antiderivative, again using the power rule. We add 1 to the old exponent, making it 10, and multiply by 1/10, the reciprocal of the new exponent. So this is the antiderivative. Now we can switch it back to x's after you take the antiderivative. U is x cubed plus 3x. that is the answer for 3. Number 4, this is going to be u sub. And if you notice, if we make u the inside function 3 plus x to the 4th, we're in luck because du contains a factor of x cubed. Du is 4x cubed dx. Now, if we didn't have this x cubed up here already, we could not go ahead with this u substitution because you can't do u sub without having the factors of du. And you're only allowed to put in missing factors that are constants, not x's. So we would pull the 5 out. If there's a constant multiplier, pull it out right away. Then you want to put in any missing factors of du, and this time we're missing a 4. So we can put a 4 in and divide by 4 on the outside. Now you rewrite in terms of u and du, so you should still have the integral sign, and it's du over the square root of u. Now, this is the power rule. Unless you have du over u to the first, if you have du over u to any other exponent, you need to first bring it up to the numerator so you can use the power rule. So first, before we take the antiderivative, we're going to rewrite this as the integral of u to the negative 1/2 du. So du over u to any other power other than 1, bring it up with a negative exponent first. Now we apply the power rule, so we add 1 to the old exponent, making it 1/2. Negative 1/2 plus 2/2 1/2. Then you multiply by 2. So we have 10/4 out front. So for our final answer, we would have 10/4 or 5/2 square root of u. U to the half is a square root. And u is 3 plus x to the 4th. And no, you do not have to write it with the radical. Okay, moving on to number 5. Okay, 5. Again, this is not a familiar integration formula. We're going to use u sub. I think I will first pull out the 3 in the denominator. So what I'm really pulling out is a 1/3. When you pull a constant out in the denominator, remember it's 1 over that constant. So we have cosine x over sine x minus 1 to the 4th. Okay, so let's see if we could make u the inside function. If we let u equal sine x minus 1, du equals cosine x. And we have a cosine x. So that's good, because if we didn't have it, we couldn't have done this. And in this case, we do not need to multiply by any missing factors of du. There's only, oh, I forgot my dx. Sorry about that. Yeah, we've got it. So we're just going to rewrite the integral in terms of u and du. So we have the 3rd on the outside, and we have du over u to the 4th. So again, we wound up with du over power of u that was not 1. So we need to first bring it up with a negative exponent. So we're integrating u to the negative 4th du. Now you can apply the power rule. You're going to add 1 to the old exponent. Negative 4 plus 1 is negative 3. So you need to multiply by a negative 1/3. So we have negative 1/9 u to the negative 3 plus c. And u is sine x plus 1. Minus 1, sorry. And you could rewrite that if you wanted to write it without a negative exponent. You could also write this as negative 1 over 9 times minus 1 cubed plus c. That'd be up to you. You ready? Next. Okay, number 6. First, we're going to pull out the constant multiplier. We have a 5 in the numerator and a 2 in the denominator. So let's first pull out the constant multiplier. 10 of 7x. Hopefully, as you look at this, you say, oh, I know secant squared is the derivative of tan. Okay, so if you realize that, you'll see this is probably going to be a du over u. So we're going to let u equal tan x, and then we'll see if we've got the important x factors contained in an x for du. Well, oops, I wrote tan of x, excuse me. It's tan of 7x. Okay, whenever you're going from u to du, and u is a composition of functions, don't forget about the chain rule. So du is secant squared of 7x times 7, the derivative of the inside. So we actually are missing a factor of du. We're missing the 7. So I need to put that in here and put a 1/7 out here. Now when we rewrite this, we have 5/14, the integral of du over u. This time, because it's just du over u to the first, we will bring it up with a negative exponent. When you integrate du over u, you get the ln of the absolute value of u. And so our final answer then, converting it back to x's, would be 5/14 times the ln of tan of 7x plus 6. All right, moving this up to 7. Number 7, okay. This one we can just rewrite it. Let's just rewrite this as the integral of, remember, you want to write them when you just have powers of x as the coefficient. Now it's not 10, it's 1/10 because the 10 is in the denominator. X to an exponent. Now it's power over root, so 2 over 3, but because it's in the denominator, it's negative 2 over 3. So by rewriting it, we can now use the power rule. And it doesn't matter whether you pull out the 1/10 or not. You get the same answer. I'll leave it in there. So first we're going to add 1 or 3/3 to the old exponent, and that's positive 1/3. So that means we have to multiply by 3 over 1, positive 3 over 1. So we have out front, 3 times 1/10 is 3/10. Let's see. And so this was just a nice power rule on x. It wasn't on some other quantity u, so we're finished. 8. Okay, so once again, we are going to pull out the half. And then what we're left with is cosecant of 6x. Well, we're not going to make u cosecant of 6x, the whole denominator, because we don't have any x's for du up in the numerator. So we're going to allow u just to be x. So du is just 6 dx. So we are missing a 6, so we're going to put the 6 in, and a 1/6 on the outside. So now when we rewrite it, we have 1/12 times the integral of 1 over cosecant u, and then that's 6 dx, that's just du, which I could put up top or I could put to the side. And then you're probably disappointed because you say, oh, I don't have a formula for this. But hopefully you realize that cosecant is the reciprocal of sine. And when you have reciprocals, 1 over 1 is equal to the other. So I can replace 1 over cosecant u with sine u. So I just had to apply a little trig identity. Now, yes, we have an integration formula. The antiderivative of sine is negative cosine. So we have negative cosine u times 1/12, or negative 1 times the cosine of u. We've taken the antiderivative. Now we switch it back to x's, and so our final answer is negative 1/12 times the cosine of 6x plus c. Number 9. Number 9, I'm going to pull the 2 out. So we have the integral of, and I think I'm going to use my fractional exponents right away. So let's just rewrite this as 4x plus 1 power over root, so it's to the 8 over 3. So this is not just x to the 8 thirds, it's something else, some other function, so we need u sub. So u equals 4x plus 1 du is then equal to the derivative du dx, which is 4 times dx. We are missing the factor of 4, so we put a 4 in and a 1/4 on the outside. Now when we rewrite this, we have 1/2 the integral of u to the 8 thirds du, right? This is just your du. Now we take the antiderivative, we add 1 or 3/3 to the old exponent, giving us 11 thirds. So we have to multiply by 3 11ths. 3 11ths times 1/2 is 3/22. Beautiful. And now we just got to put it back. So we're going to convert it back to x's. And I think I'm just going to leave it like that instead of writing it in radical form. 4x plus 1. Okay. Number 10. 10, when you look at these, there's a 1 up here if you don't see a number. If you see something and its derivative, the something is the u. So in this case, we want to make the u ln of x. Now remember, I had those 3 what I call tricky u's where the du is a fraction. And with those, it's easier to see when you break it up. So instead of having it just division, I'm going to just write it as, I'm going to write it as a product. It's the integral of 1 over the ln of x times the 1 over x. You do not have to do this. It just helps people see it a little better. So when you suspect that u is either ln of x, rad x, or 1 over x, it's nice to rewrite the quotient as a product. Okay, so now if u is ln of x, du is 1 over x. We don't need any factors, we just convert it. So we have the integral of 1 over u du, or du over u, which equals ln of the absolute value of u plus c. We took the antiderivative, we converted back, substituting in for u of x, and yeah, it's a weird answer. There we go. The ln of x plus c. Oops, number 11 must be down here. There it is. Okay, 11. If you remember, when you just have to integrate tan or cotan, you need to remember you first must rewrite it as a quotient. Now, cotan is cosine over sine. So we're integrating the cosine of 3x over the sine of 3x. Once you do that, now you can just let the denominator be your u. U equals sine of 3x. Remember, going from u to du, if u is a composition of functions, use that chain rule. So du is cosine of 3x times 3 dx. So we're missing this 3. You put it in there. We put a third on the outside. So we have, when we rewrite it, 1/3 times the integral of du over u, which is 1/3 the ln of the absolute value of u plus c. And our final answer is 1/3 times the ln of sine of 3x plus c. Number 12. 12, let's pull that -6 right out front. So we have -6 times the antiderivative of e to the cosine of 2x, and then times sine of 2x dx. All right, so this is looking like an e to the u du problem. So we want to let u equal cosine of 2x. Du, the derivative, remember you go down a level, is negative sine. Negative sine of 2x times 2. Now we look for missing factors. Well, we need the 2 and we need the negative 1. So if we put a negative 2 in, we need to divide by negative 2 on the outside. Now when we rewrite this in terms of u, outside we have negative 6 over negative 2, which is positive 3. This is the integral to the u du. And when you integrate e to the u, as long as you have du, right, any of these formulas only work with u's if you have du, you get e to the u plus c. So our final answer when we convert it back is e to the cosine of 2x plus c. Moving on to number 13. Oh, no, guess not. 13, let's move it down here. Okay, 13, if you were tempted to make u the denominator, the numerator doesn't look at all like du. It's not off du by a constant, so that's not what it is. You just need to actually do the division first. When you're integrating a product or quotient, you're going to have to act, unless you're using u sub, you're going to actually have to do the multiplication first or do the division first. So we're going to divide first. Now, I normally just divide each term of the numerator by the denominator. I find a lot of you guys like bringing the x to the half, like in the denominator up, and then distributing. So I'll do it that way this time. So let's just rewrite this as 3x squared minus 5x plus x to the half minus 2. And then instead of dividing each term by x to the positive a half, I'll bring it up and multiply each term by x to the negative 1/2. So I've got a product now instead of a quotient. But I still have to multiply it out. I still need to distribute. When you multiply with the same base, you add exponents. So when I distribute, the first term is 3x to the, when you add 2 and negative a half, you get 3/2. So to the 3/2. Minus 5. If you add the 1 and the negative a half, you get positive 1/2. So 5x to the positive a half. When you multiply x to the half by x to the negative a half, you get x to the 0, which is just 1. And then you distribute to the negative 2, and we have minus 2x to the negative 1/2. So if you don't like dividing each term by x to the half and subtracting exponents, you could bring it up to the numerator using a negative exponent and multiply by adding exponents. Okay, so we're just going to go through term by term. So for the first term, you add 1 or 2 halves. So that means you need to multiply by 2/5, so you get 6/5. Next term, you add 1 to the exponent, giving you 3/2, which means you multiply by 2/3. When you take the antiderivative of 1 with respect to x, you just get x, right? Because 1 is the derivative of x. Next term, you add 1 to the old exponent, giving you positive a half. So that means you need to multiply by positive 2. So it's minus 4 out front. And there you go. So no u sub on that one. 14. Well, when you have to integrate secant x, you got to remember what we did. There was something I gave you, showed you in class. I said, once I show it to you, you just got to remember the technique. So what we do is, to integrate the secant of x, we multiply by crazy form of the number 1, right? 1 is anything over itself. And that is secant x plus tan x over secant x plus tan x. And when you do that, when you multiply, right, you distribute the numerator. You have secant squared x plus secant x tan x over secant x plus tan x. And if you take a look at this, if you look at that denominator, secant x plus tan x, you realize, oh, the numerator is its derivative. The order switched. So we're going to use u substitution now. We let u equal the denominator, secant x plus tan x. So du is equal to the derivative of secant x, which would be secant x tan x, plus the derivative of tan x, which is secant squared x, and then we're multiplying by dx, because that was the du dx by dx. So we're not actually missing anything up there. We have it. It's just the opposite order. It doesn't matter with changing the order with addition. It's commutative. So we rewrite this as the integral of du over u, which is natural log absolute value of u, which gives you the natural log of the absolute value of secant x plus tan x. That was fun. Okay, that was 14. Moving on to 15. Okay, 15. Well, hopefully you see this is just going to be an e to the u du. Okay, there's nothing to pull out, so we can go ahead and let u equal 5x. So du equals 5 dx. We're missing the factor of 5, so we put it in a 1/5 on the outside. And so when we rewrite this in terms of u, we have 1/5 times the integral of e to the u, right? The 5x is u, and 5 dx is just du. Now we can go ahead and get the antiderivative, which is just e to the u, and then we switch it back to u's. E to the 5x plus c. Okay, moving on, 16. Okay, now 16, no constant to pull out because that pi is a constant, but it's being raised to an exponent. It has to be a constant multiplier to be pulled out. So there's nothing to pull out. But this is going to be that a to the u rule. Right? So I am going to do one thing. I'm going to rewrite that. Instead of rewriting it as x over 2, I'm going to write that as 1/2 x. Right? It's always nice to rewrite as a coefficient, a constant, times x to a power. So this is the a to the u rule. So if we want this to be the a to the u rule, with a being pi, we are going to allow u, we're going to let u equal 1/2 x. So du is the derivative of that times dx. So 1/2 dx. We are missing the half. Right? We put the half in. So we put a 2 on the outside. Now we can convert it over to u and u. So now it's pi to the u du. Now when you take the antiderivative of a to the u, you get a to the u, so you'll get pi to the u, but then you have to divide when you take the antiderivative by the ln of a. So by the ln of pi, and then plus c. Our final answer is, you can put the 2 up in the numerator if you like, or leave it out front. 2 times pi to the x over 2, or 1/2 x, all over the ln of pi. Okay. Number 17. 17, I see I have a constant multiplier of 3 down in the denominator, so when I pull it out front, I have a 1/3. So I have a sine rad x over rad x. When you suspect that u is either rad x, ln of x, or 1 over x, it's a good idea to write it as a product. So we're going to rewrite this as 1/3 times the integral of sine rad x, right, the function of u, and you want to multiply by 1 over rad x. Right? When you divide by anything, it's the same as multiplying by the reciprocal. But that is going to allow us to see du a little more clearly. So if u equals rad x, x to the half, this is when you just want to know by heart. Du with 1/2 x to the negative a half which is the same as 1 over 2 rad x, right? The derivative of rad x is 1 over 2 rad x. Now, we see what we're missing. We have the 1 over rad x, but we don't have the half. We don't have the 2 in the denominator, right? So we're missing a 2 down here, which is really means we're multiplying by 1/2 inside. So we multiply by 2 over 1 outside. So we get 2/3 times the integral of sine of u, all that is just u. This gives us 2/3 times negative cosine u, so I'm going to put a negative 2/3 cosine u. And so our final answer is negative 2/3 cosine of rad x plus c. Okay, number 18. 18, nothing to pull out, that we can't pull out the 3. It's not a constant multiplier, right? So this is the a to the u. We're going to let u equal cosecant of 3x. So we'll get du with the chain rule. So it's the derivative of cosecant is negative cosecant cotan. So it's negative cosecant of 3x cotan of 3x times 3. So when I look up here, I see we're not only missing the 3, we're missing the negative 1. So we got to multiply somewhere in here by negative 3, and then on the outside by negative 1/3. So now when we rewrite this, we've got negative 1/3 times the integral of 3 to the u du. And when you integrate a to the u, you get a to the u, so we'll get 3 to the u over the ln of a, the ln of 3 plus c. So our final answer is negative 3 to the cosecant of 3x over 3 ln of 3. So 19, you're probably tempted to let u equal 1 plus 25x squared. But if we did that, then du would be 50x, and we don't have an x up there. So that's your sign. This is going to be an inverse trig. But before I get ahead of myself, let me pull that 7 out front. That's a constant multiplier. So now up top, we just have the 1. Okay. So now that we know we're going to be going for inverse trig, the first extra step is that making sure that the constant in the denominator, the constant that's alone, this one here, is a 1, not some other number. Well, we got lucky in this case. It is a 1. So we don't have to factor it out. The second extra step with inverse trig is to identify u squared. Now, u squared is going to be the squared term in the denominator after the constant is a 1. So that's going to be the 25 squared. To go from u squared to u, you're going to take the square root, so it'll be 5x. Now it's like every other u sub problem. You got to get your du, which is 5 dx. We're missing the 5. So we multiply by 5 inside and divide by 5 on the outside. We rewrite it as 7/5. The numerator of the integral is just du. The denominator is 1 plus u squared. So we rewrite the integral in terms of u and du. Then we actually get the antiderivative, which would be 7/5 inverse tan of u. Then you switch it back to x's, 7/5 times the inverse tan of 5x plus c. Okay, I'm going to pull that 3 out front. And when I do that, now again, I'm very tempted to let u equal the inside function down there. But if I did let u equal 4 minus 16x squared, du would be negative 32x, and I don't have an x up there. Again, when you don't have enough x's up there, it's probably going to be inverse trig. So when you're going for inverse trig, let's first make sure that the constant in the denominator is a 1. Well, it's not a 1, so you're going to have to factor out whatever it is. So we are going to factor that square root of 4 minus 16x squared. We're going to factor it square root of 4. And to figure out what the other factor is, if you pulled out a 4 out of the radical, then you need to divide each term by 4. So you have 1 minus 16x squared over 4 would just be 4x squared. You can always take a second and check if you distribute the 4 back, if you would be back to the original denominator. Okay, so that's right. Now this square root of 4 here, we're going to pull it out front. It has to be in the denominator, all right? So I could write out front 3 over rad 4, or I could just write 3 over 2. So I think I'm going to write it like that. So we have 3 over 2 times the integral of 1 over the square root of 1 minus 4x squared. So our first step was to get that constant out in the denominator to be a 1. Now we identified the squared term down there, which is going to be 4x squared, meaning that u would equal x. Oops, I said dx, so I don't mean that now. It's the square root. And so d is equal to 2 times dx. So we are missing 2 into u. So we go over here, we multiply by 2. So we have to also multiply by a half or divide by 2. Now we rewrite it as 3/4 times the antiderivative of du over the square root of 1 minus u squared. That equals the inverse sine of we've taken the antiderivative, now we convert it back to x's, so our final answer is 3 times the inverse sine of 2x plus c. Okay, the next one. I don't think I'm not going to, well, I know I'm not going to put an inverse secant on here, but I'm going to show you anyway, okay, for anybody that's interested. So first thing I'm going to do is pull out the 7. So I have a 1 over x rad 25x squared minus 1. Now I'm lucky because, well, first of all, if I make u 25x squared minus 1, du would be 50x. I would need an x in the numerator, which I don't have. So I am going for inverse trig, and this is the inverse secant, which is the annoying one. So at least the constant down here is a 1 already. I don't have to do that. So I will then identify u squared, which would be the 25x squared, making u 5x, and du is equal to 5 dx. Now, you say, okay, I'm missing, we're so used to, we only look for any missing factors of u, all right? But before I actually go and put that in there, I just want to remind you of the inverse secant, the integral leading to inverse secant. That is the integral of du over u times the square root of u squared minus 1 equals the inverse absolute value of u plus c. Not only do we have to have a du up in the numerator for this formula, but we have to have the u out front. So to have du up in the numerator, I'm missing a 5. I put a 5 up here. But I'm also missing, to have my u down here, I'm missing a 5 out front in the denominator. So I don't have to compensate outside because what I've really multiplied inside by is 5 over 5. We needed 5 in the numerator for the factors of du, and we needed a 5 in the denominator for the factors of u. So now when I convert this, I just have 7 times the integral of du over u rad u squared minus 1, which equals, oh, I can be lazy here. So it equals 7 times the inverse secant, absolute value of u, which equals 7 times the inverse secant, absolute value of 5x plus c. Okay, 22. We're given the second derivative. The notation might have bothered people, so let me write it another way here. We're given the second derivative of the function x equals 5x plus 2. We're told the first derivative is equal to 2 when x equals 0. So f prime of 0 equals 2, and y equals negative 3 when x is 0. So f of 0 equals negative 3. So we want to get the function f of x. So starting with the second derivative, we're going to take the antiderivative, which will give us the first derivative. So to get the first derivative, or dy dx, we're going to take the antiderivative of the second derivative, which gives us 5 halves squared plus 2x plus c. Now we will plug in the point on the graph of the first derivative, which was when x is 0, the derivative is 2. So 2 equals 5 halves 0 squared plus 2 times 0 plus c. That means that for this first derivative, c equals 2. So now, plugging it back in, we know that the first derivative is 5 halves x squared plus 2x plus 2. Now we're going to go again, but now we're going to take the antiderivative of that to get the function. So let me just go over here. So to get the function, we'll take the antiderivative of the first derivative, which we got 5 halves x squared plus 2x plus 2. So 5 halves x squared, we add 1 to the exponent, that's x cubed, so we multiply by a third. So 5, 6x cubed, plus we have x squared plus 2x plus c. Now we just got to get c for our function. So we plug in negative 3 for the f of x. We plug in 0 for all the x's. And that means that c equals negative 3. So our final answer of x equals 5, 6x cubed plus x squared plus 2x minus 3. So when you integrate, you are going to wind up with a plus c with an indefinite integral, which is what we've been doing. Okay, 23. Okay, we're given the first derivative. We're giving 1 point on the graph of the function, and we want the function. So this time we only have to go up 1 step. So to get the function, we're going to take the antiderivative of the first derivative. So of 3 sine x minus 2 cosine x. So we take the antiderivative. Now remember, the antiderivative of sine is negative cosine. So it would be negative cosine x. Antiderivative cosine is sine, so minus 2 sine x plus c. Then we use the given point to find c. So we put 6 in for y and 0 in for x. Now, think of your unit circle. When you're over here at 0, the cosine is 1, the x-coordinate, the sine is 0. So I have 6 is equal to negative 3 times 1 minus 2 times 0 plus c. So if we add 3 to both sides, we get c equals 9. So our final answer, y equals negative 3 cosine x minus 2 sine x plus 9. Okay, 45 minutes. All right, that's not enough because I don't want you guys to be bored for the rest of your weekend. So what I was thinking is the day before, I think it was 67, I had 3 do now problems with the tricky U's. So I'm just going to do each of those also, just to give you more practice. Okay, so for the first time, for the first one, there were 3 of them. Don't worry, it's not much longer. You can always hit stop now if you want. But I'm going to pull out this 2 down here. So when I pull it out, it's a half out front. And so I have the sine of ln of x over x. When your inside function is ln of x, that's one of those. We want to first break it up. Instead of looking like a quotient, we're going to break it up to look like a product. So I'm going to rewrite it as the sine of the ln of x, the function of ln of x, times 1 over x. Right? When you divide by x, it's the same as multiplying by 1 over x. Now, when we let u equal the ln of x, du equals 1 over x dx. We've got it. So now when we rewrite this, we have 1/2 the antiderivative of sine u du. When you take the antiderivative of sine, you go up a level, so it's negative cosine. So we have negative 1/2 cosine of u plus c. So we have negative 1/2 sine of the ln of x plus c. All right, let's try the second one. Second one. I don't know. That's just going to stay. All right, I will pull the 3 out of the denominator. So we have a 1/3 times the integral of secant squared rad x over rad x. So you're thinking, oh, if it was secant squared u, I would know what the antiderivative is. Okay. So again, if u is one of those tricky ones, and I call them tricky only because the du's turn out to be fractions. It might help you to rewrite this as a product. Secant squared rad x times 1 over rad x. So if we let u equal rad x du, it's a 1/2 x to the negative 1/2, but this one you'd like to know by heart, 1 over 2 rad x dx. So when you take a look to see if you have your factors of du, you say, oh yeah, I'm missing a 2, but it's in the denominator. So if you put a 2 down here, what you're really multiplying by is a 1/2 inside. So you need to multiply by 2 over 1 on the outside. So we get 2/3 the antiderivative secant squared u du, which equals 2/3 the tan of u. Converted back in our final answer, 2/3 times the tan of rad x plus c. And I have one more of those. I wanted you to see examples for all 3 of them, the ln of x, rad x, and 1 over x. So our last example, we've got this one here. I'm going to pull that 1 over pi out front, pull out that constant multiplier. So we have e to the 1 over x over x squared. So we'd like this to be an e to the u du. So we're going to, because it's a 1 over x for the u, that's the other one, it might help you to write it as a product. So e to the 1 over x times 1 over x squared. So u is equal to 1 over x, or x to the negative 1. du would equal negative 1x to the negative 2, or negative 1 over x squared dx. That's a really good one to know by heart also. The derivative of 1 over x is negative 1 over x squared. You are missing a factor of negative 1. So I put a negative 1 inside, we multiply by negative 1 inside, and the reciprocal of negative 1 is also negative 1, so on the outside. So we have negative 1 over pi, the e to the u du. So you have negative 1 over pi. antiderivative of e to the u, if you have the u, is e to the u. And so our final answer is negative 1 over pi times e to the 1 over x plus c. That is good. All right, 50 minutes. I don't know. Maybe you could play it again if you're still bored. All right, let's see if I can get this up here.